Science of Synthesis, your expert guide to making molecules. The purpose of this video is to give you a brief introduction to science of synthesis and to show you how you can use it to help with your research.
The Science of Synthesis series, which has been an essential part of our laboratory's library for a very long time now. We use the online version, we use the text one, as you can see right behind me. And it has been a really integral part, at least of my life, in the way I go about brainstorming for projects in the laboratory, finding literature which is sometimes very obscure and hard to find on SciFinder, or for solving very difficult consulting problems. So I'm really grateful to Team A for putting together this amazing series and continuing this wonderful tradition. It's a huge help to the community. Fantastic trove of information which you may not be able to find anywhere else, and it's so beautifully organized, and thank all the contributors over the years for their diligence and hard work in putting this together.
Hi, this is Shuli Yu from SLC. Science of Synthesis is a unique reference work which covers all methods of organic synthesis, offering the full text descriptions of organic transformations together with validated experimental procedures. I really like this feature, which saves us a lot of time during our research. The online version is also really amazing and entirely searchable based on the structures, substructures, and reaction types.
Science of Synthesis is the largest collection of evaluated organic synthetic methods available worldwide. It gives you access to more than 20,000 reliable synthetic methods that have been evaluated and reviewed by world-renowned experts. It's an author-written full-text resource rather than just a database. This means it's not just a huge collection of unconnected molecules and reactions, but has a logical structure that enables you to navigate through it easily. So why choose Science of Synthesis? A community of experts means quality and reliability. They are giving you unique insights into the science, the tips and tricks to solve your synthesis problem. By getting a quick overview of a new subject area, you can save time when planning a synthesis. The practical procedures are immediately applicable in the lab and give you an idea of the reagents and equipment you'll need. The methods are organized logically, according to the functional group or core product made, and this puts the methods in context and is also helpful for consulting and teaching. In a nutshell, some of the questions that Science of Synthesis can help you answer are: what is the best way to make the molecule or functionality I'm interested in? What is the background and context to the field of research I'm interested in? What are the experimental conditions like? Am I going to need specialist equipment? Is there anything I need to consider or avoid when making the molecule or functionality I'm interested in? The Science of Synthesis editorial board, led by Professor Förstner, are world-renowned organic chemists from all over the world, from both academia and industry. These people, together with the editors and authors they appoint, drive Science of Synthesis and decide what should be included and where the focus should be. Some 2,000 editors and authors have been involved in Science of Synthesis to date and can be found on the author map at teamofchemistry.com. Science of Synthesis is unique in that it provides critical reviews on synthetic methodology in organic and organometallic chemistry. It is organized systematically and logically based on the product, specifically the main functional group being made, and it is structure and text searchable online. Chemistry doesn't stand still though, so we are always adding new reliable synthetic methods, expanding on the scope of existing methods, and adding new reagents and conditions in the Science of Synthesis knowledge updates. The reference library complements the core content by focusing on subjects of particular interest without constraining it by product. The functional group you make is secondary. It's the type of method you use to get there that is the important thing. So what can I do with reagents of type Y, rather than how do I make functional group X? Recent reference library titles include photocatalysis, flow chemistry, dual catalysis, and the application of boron reagents. The organizational structure of the core of science of synthesis is based on the type of molecule or functional group you are interested in making, whether that be organometallic, a heterene, a particular functional group, or a hydrocarbon, and we'll see this later in the product demonstration. Of course, we realize that this type of organization doesn't fit with all areas of chemistry, so to complement the core product-based structure, the special hot topics in the reference library focus on methodology or on important techniques or technologies. The key point about science of synthesis is that it presents chemistry in context. Each full-text article has the same basic layout, making science of synthesis very user-friendly. As well as discussion of the synthetic method, the scope and limitation of the reactions are discussed. Where possible, science of synthesis includes the full preparative details for each reaction. The reviews in science of synthesis are text and structure searchable in the electronic product. At sos.tema.com, on the home page, you see various tiles on which the different types of product are displayed. As mentioned before, science of synthesis is based on the type of product you want to make. So here we have the tiles grouping organometallics, heterenes, hydrocarbons, and all the functional groups in between. By mousing over any of the topics listed, you see a graphical representation, a summary of the types of product that are covered in each volume. Clicking on any link on these tiles takes you to the Explore Contents tab where you can browse. As an example, let's say you are interested in making an aldehyde. By clicking into the link, you are taken to the Explore Contents tab where you see all the various types of aldehyde. So let's go further. Let's say we want to make an acyclic aldehyde, and let's make it by oxidation of a primary alcohol. Now we see several routes via the oxidation of primary alcohols, but also see that there are other ways to get to an aldehyde by oxidation too. Within this first method, which uses chromium reagents for the oxidation reaction, tips and tricks are discussed in the text. For example, using a polymer-supported reagent to ease purification, or the addition of acid to speed up the reaction, the need to maybe buffer the reaction if your substrate is acid sensitive. These points are scattered throughout the primary literature, but here everything is gathered in one place. If we scroll through the method, you see tabulated examples in the schemes, showing the scope of the reaction, experimental procedures, where appropriate with safety information, and of course references to the primary literature, which you can access by clicking on the link out, which takes you to the original literature at the publisher website. You can download the whole chapter by clicking on the first button. And to just download or print the section you are currently looking at, you click on the printer symbol. If you use citation management software, like EndNote, you can export the citation to your citation library using the pencil tool. Back on the Start page, the tile with Trends and Innovation contains the reference library titles, which focus on hot topics in synthesis. The methodology rather than the functional group is the focus here. The how rather than the what. These can be browsed in the same way using the Explore Contents tab. You can get a brief overview of what is in a chapter by looking at the abstract. You can also download chapters directly from the Explore Contents tab without going into the full text. To do a more targeted search on the home page, you can do a text search in the box at the top. So let's search for pyrosols and click Submit. This takes you straight to the Results tab where you see your hit list, which you can sort by relevance, which is the default, or by publication date. Here you have a review from 2002 and an update from 2017. You can also search by concept rather than type of molecule. So let's search for enantioselective aziridination. Here again, you see discussion text comparing the various reagents, along with a scheme and table showing the scope of the reaction and representative procedures. If you want to search by author name, this can also be done in the text box. On the Results tab, you can then filter by whether the name appears in the references, within the discussion text, or whether the chapter was written by that person. More unusually for a reference work, you can search Science of Synthesis by structure or reaction. To do this, click on Draw, the pencil icon on the Start page. The drawing panel is simple to use. Add ring systems using the Ring Systems template, add bonds using the Draw Bond menu, and introduce atoms using the Draw Atom menu. If you prefer, you can also upload a structure or reaction from ChemDraw by clicking on Upload and navigating to the ChemDraw or mol file you wish to use. Let's search for 3-methyl-indole. First, we'll draw the basic ring structure. Add the methyl group and then the nitrogen atom to the ring. I've done this by choosing the atom from the Draw Atom menu, but you can add atoms by typing them in. Just make sure that there is a blue box at the end of the bond you're adding to. The most common elements are listed in the Draw Atom menu, but you can choose any other element from the periodic table. Click Submit to go to the results page, where you will see the bibliographic details, chapter title, author, etc., and the reaction or structure that you've just searched for. You can filter by defining whether you want the molecule you are searching for to be the reactant or product of the reaction, and by what type of match it is, exact, substructure, or similar, which you should be familiar with. The main difference between Science of Synthesis and SciFinder or Reaxys is that the data set in Science of Synthesis is significantly smaller. This is because these are the pre-selected best synthetic methods, the filtering of which reactions are most likely to work, has already been done, and not every single example of a reaction or structure has been included. Because of this, we recommend that when doing a structure search, you keep the molecule as simple as possible. Focus on the functional group or groups that you are really interested in, the ones that are most significant to the transformation you wish to undertake, in order to get the best results from Science of Synthesis. For more complicated molecules that you don't want to draw, but still want to do a structure search for, you can use the name to structure function. For example, let's use 4-aza-indole, which is a trivial name for a pyrrolo-32B pyridine. In the fourth entry here, let's show this method of synthesis in context. If you jump from the full text or even from the Results tab into the Explore Contents tab, you can see other routes to make this bond en route to an aza-indole, which puts the chemistry into context. Back in the full text, you can navigate to the next method using the arrows on the right, just like you would browse through a book, and you can jump to the next hit from the Results page using the Previous and Next buttons on the left. You can also combine structure and text searching. Let's clear the structure editor and draw a triazole and click to submit. To refine this search, go back to the Query tab and add to the text box. Let's add Stetter to view a more focused set of results, showing only instances where triazoles or triazolium salts have been used as catalyst in Stetter reactions. Reaction searches are also possible. Here, a simple reaction transforming a benzyl alcohol into a benzyl fluoride. You can use the common keyboard shortcuts Ctrl-C and Ctrl-V to copy and paste structures within the editor. Change the atom in the second molecule from oxygen to fluorine by selecting it and typing the element symbol in. Submit to go to the results page, where you can again filter by the type of reaction, with exact match being given the highest priority in the ranking. Again, the scope of the reaction is described in the text, and a scheme and representative experimental procedure is given. You can also search for half reactions. So if you know what you want to make but are not sure how best to get there, you can search for your product with an arrow going to it to get different hits with other suggested routes to the molecules you're interested in. More advanced searches can be carried out, for instance using atom mapping to show the transformation of one functional group in the presence of another, without affecting the second functional group. This is done by using the Enhanced Chemical Functionality button, the flask and the spanner, and choosing Atom Mapping. Click on the carbon at the reaction center of the first functional group and map to the same carbon in the product, and do the same for the second functional group. In this case, we're looking at reducing a ketone in the presence of a carboxylic acid or ester. You can create lists of variable atoms at a center by right-clicking at the end of a bond, choosing the Edit Atom function, and then choosing List, and highlighting the elements in the periodic table that you want to search for. To add functional group abbreviations, select the bond you wish to add to. It should have a blue dot at the end of it if you've just drawn it. Otherwise, select it by clicking the yellow post-it tool in the menu to make sure it is the active atom. And then type the group you want to add and press return. The functional group abbreviations are case sensitive. You can also add to several atoms at the same time by using the other select tool and dragging the box over the bond ends to select them, typing in the element symbol or functional group and pressing return. The final way to search is a citation search, which is useful if you have a page or section number you want to look up, if you've seen Science of Synthesis cited elsewhere. To summarize, Science of Synthesis can be searched like a database, but has the full text content of a reference work. It should be viewed as a valuable complement to SciFinder and Reaxys when you're moving into a new area, want to make a new type of molecule, or want to learn the basics about that type of molecule and how best to make it. Science of Synthesis is the best place to start. SciFinder or Reaxys are great for finding specific molecules and transformations, but if you do a more general search, you will get hundreds, possibly thousands of hits and not know where to start. Science of Synthesis gives you that pre-filtering and gives you the key information you need so that you can plan your synthesis. Case studies can be found on the website at www.tema-chemistry.com. If you're interested in doing a case study, please contact us. Please follow us on Twitter or on Facebook and sign up for the newsletter on our website.